In this video, we'll be learning on how to find the domain, range, asymptotes of rational functions and its graph. The domain of the rational function f of x is the set of real numbers except those values of x that will make the denominator 0. In set notation, we can write the domain as the domain of function equals the set of x such that x is an element of real numbers except x equals a, where q of a equals 0. And range is a set of all values that the functions f takes, and it is also the solutions along the vertical axis. So next is the asymptote, where its denominator equals 0. We call that as vertical asymptote. And for horizontal asymptote, we have case 1 to 3. Case 1, if the degree of the numerator and denominator is equal, then we will use y equals the ratio of the leading coefficient. And for case 2, if the degree of the numerator is less than the degree of the denominator, then we will use y equals 0. In case 3, if the degree of the numerator is higher, then we can say that there is no horizontal asymptote but an oblique asymptote. So now let's proceed to our illustrative example number 4. Given the function f of x equals 3x minus 2 all over 4x minus 5, then find the domain, range, vertical and horizontal asymptotes. So here is our solution. For the domain, f of x equals 3x minus 2 and 4x minus 5, first we need to equate the denominator to 0. Then that's it, we need to take out 4x minus 5, then equate to 0 there. Then what we have now is 4x equals 5 by additive property of equality. Then isolate x, divide both sides by 4, we can cancel out positive 4 from the numerator and the denominator, and then this will give us x equals 5 over 4. It means that the domain of the function is the set of all x such that x is an element of real number where x is not equals to 5 over 4. Because if our x is equals to 5 over 4, then our function will lead us to undefined solution. So that is why we will not include the value 5 over 4 as the domain of our function. So meaning all real numbers except x equals 5 over 4. Okay? So again, that's how we write the domain of our given function. Now let's proceed to finding the range of the function. Since f of x equals y, then we can say, or we can translate it into y equals 3x minus 2 all over 4x minus 5. We need to find the inverse by exchanging the position of x and y so that it will give us x equals 3y minus 2 over 4y minus 5. Okay, so again we exchange the position of x and y, so that makes it x equals 3y minus 2 all over 4y minus 5. Then solving for y, here cross multiply x times 4y minus 5 equals 3y minus 2. Then we have there 4xy multiplying x times 4y, and then x times negative 5 will give us negative 5x. So in our left hand side will give us 4xy minus 5x, then equals 3y minus 2. Then by additive property of equality will give us 4xy minus 3y equals 5x minus 2. Factor out y times the quantity of 4x minus 3, because y is the common factor of the two given terms 4xy and negative 3y, then equals 5x minus 2. Then we will divide both sides by 4x minus 3 so that we can solve for y. Then we can cancel out the quantity of 4x minus 3, and then this will give us y equals 5x minus 2 all over 4x minus 3. But we need only to get the denominator for us to determine the range. Then this will give us 4x minus 3 equals 0. Then solving for x will give us 4x equals 3, and divide both sides by 4, and that will give us x equals 3/4. So this means that the range is the set of all real numbers except y equals 3/4. Then we can write the range of the function as the set of all y, such that y is an element of real numbers where y is not equals to 3/4. Right? So that's it on how to find the domain and range of the function. Now let's proceed to finding the asymptote of the function. So the vertical asymptote, where its denominator equals 0. So it means that this is just the same as our domain, because we are going to find the 0 of the denominator. Then here is the solution. So again, we need the data from the denominator and equate that quantity into 0. Then that will give us 4x minus 5 equals 0. There. Then simplify, that will give us 4x equals 5, then divide both sides by 4 will give us 5/4. So therefore the vertical asymptote is x equals 5/4, which is also equals to our domain earlier. So in finding the horizontal asymptote, so since f of x equals 3x minus 2 all over 4x minus 5, it is under case 1 if the degree of the numerator and the denominator is equal, then use y equals the ratio of the leading coefficient. So since the degree of the polynomial in the numerator is 1 because the exponent of x is only 1, and the degree of the denominator of our polynomial is also 1 since the exponent of x equals 1, so meaning they are equal. So we are going to use the ratio of the leading coefficient of those variables. Horizontal asymptote is y equals 3/4. And that's it for the vertical and horizontal asymptote. Now let's move on to the graphing of rational functions. So given again f of x equals 3x minus 2 all over 4x minus 5. So we let the set of values of x, I have here -1, 0, 1, 1.5, 2, and 3. So if our x equals -1, that will give us y or f of x equals 5/9 by substituting -1 to the given function. If your x equals 0, and that will give you 2/5. If your x equals 1, that will give you -1. If your x is equals to 1.5, that will give you positive 2.5. If your x equals 2, and that will give you 4/3. If your x equals 3, and that will give you 1 as your value of f of x. So we are now going to graph this set of ordered pairs to the Cartesian plane, and this will give us the graph as this. That's it about rational functions.